Hi, and welcome back. Today I'm going to talk about overtones. Overtones are what give character to pitches. And so an ideal spring that we saw previously will produce a pure tone, it will produce a sine wave. But not everything in the world is a pure tone. A pure tone is something that sounds like this. Here we have this piano spectrogram, and you can see the pure tone only excites a single part of our ear, a single place on this spectrogram. Another wave like this square wave, it's much more buzzy, right? And it excites different parts of our ears. It's the 3 times the frequency here and 5 times the frequency here. And then it continues. This is 1, 3, 5, 7, 9. It's a repeating pattern. How does that work? Why does that happen? Well, it turns out that you can reconstruct a square wave by using a bunch of sine waves. So let's take a look over here. This purple line here is roughly a sine wave. Sorry, this purple line here is roughly a square wave. We have this fundamental frequency that has the same wavelength as that square wave, and you see it's a little bit short on the left and right. And so if we add something on the left and on the right, this is 3 times the frequency, 3 bumps. And so it makes it a little bit more square on those ends. And then we can make it even more square by adding some of this 5th one. And so that's why we see the 1, 3, 5 frequencies over here. Now, this one, the triangle wave, we've slid a little bit, there we go. This triangle wave, it also is the same 1, 3, 5. Let's see how we build a triangle wave with these pure tones. So triangle wave is something that's shaped like this, right? We have our fundamental, right? And we see that it's a little bit high on the left and the right and a little bit low in the middle. So if we subtract some of this one that's 3 times, right? We're lowering it on the left and the right, and we're adding some in the middle. And then we can get that peak, more peaky by adding some of this that's 5 times. And that's what we see over here, right? We see, let's bring it over here. This is 1, 3, 5. The same 1, 3, 5, but less of them. The saw wave is interesting because, well, it's very buzzy, but it produces all of the overtones. So you see it's at 1, 2, 3, 4, 5, 6, every single overtone. And that is essentially it. Overtones give character to the sounds, and a saw wave produces all of these. Any character in a pitch can be described with overtones, and combining those overtones can produce that same character. And that, my friends, is essentially it.